Good morning, everyone. It's a 2009 Dodge Caliber. Customer complaint, check engine light. It starts, it runs. So let's verify it. Key off. Let's see if the check engine light is not on. Somebody took the bulb probably. Or, yeah, the bulb is not there. But it started. It starts. I did a full scan. I think they meant to say it doesn't pass inspection. What is this? Aftermarket. I hate it. We have 4 codes. I scanned the vehicle. Check. We have 4 codes. P0032, oxygen sensor 1, heater circuit high. P0113, active intake air temperature sensor, circuit high. P2010, and it's an active code, intake manifold runner, control circuit high. And P2016, intake manifold runner position sensor circuit low, bank 1. Now, he did tell me that he got, this is at a local dealer, and he did tell me that he got his fake inspection. He got his mechanic to change. Oh, I didn't see that. He got his mechanic to change this and the whole runner, the whole intake manifold. Now this 2.4 engine Chrysler and a Dodge, it comes in a Sebring and in a Caliber. I think in an Avenger 4-cylinder also they put it. There's so many cars they use this engine in it, and they tend actually to get stuck. The runners for the air, they tend to get stuck, and this piece also fail. But in this case, here's signs to changing. That's why we have all these codes. Oh my God, that's another one. Look, somebody visited the junkyard. Let's see what we're dealing with here. That's not cool. I don't like it that way. Alright. So one by one, let's bring everything back to where it should be. Unplug all the sensors that they unplugged. Yeah. And see what we're dealing with. Okay, so let's clear the codes. Set up the key. Alright. So it's not stuck. It's not stuck open code. It's the control circuit high. That's he thought that it was stuck open, so that's why he changed the runner and the that control switch on the side. But let's dig into the 2010 and 2016. Going to all data, there is a procedure that we have to do to check. This is the wiring diagram for the harness for the control. 5 pins, 5 wires, 1 2 3 4, and this is the ground, the 5th one. 4 of them comes from the power, from the computer, from the engine control module, powertrain control module, and this is the 2 harnesses we're going to do our checks at. The black one here, and this one over right here that connects to the solenoid. Let me get the tripod out. The first thing we are going to check, after verifying the code, of course, which we did, MFV, which is this manifold flow valve. MFV, control circuit shorted to volt. Turn ignition off, disconnect the manifold flow valve connector, disconnect the powertrain control manifold PCM C2 harness, which should be a black as we said. Turn ignition on, measure the voltage of the K601 MFV control circuit in the manifold flow valve harness connector. There's a, I'll check. Turn ignition off. Disconnect. Harness. Let me do this. I think it has a lock. Disconnect the lock and black. Which one is the black one? Let's see. This is the black one. So connect this one back. Alright, now key on. And turn ignition on. Measure the voltage of the MFV circuit in the manifold. Alright, so pin number 3. Pin number 3, which is the top left. Top left is pin number 3. We're going to check the voltage. So I am hooked to ground. Check the voltage in here. We have 0 volts, so we don't have short to volt. There's a voltage present? No, actually go to 3. Go 3 in control circuit, open or high resistance. Measure the resistance of KMF between the manifold flow valve harness connector and the powertrain control module PCM connector. It should below 5 ohms. Okay, that is going to be pin 27 and pin number 3. So when it's here, 27 is This is 1 to 24, 25, 26, 27. Should be this one. Barely touch it. Don't spread it out. And 3. What's the... Oh, my bad. 0.4. Excellent. 0.3. Alright. Here we have continuity. Here. .4. Okay, excellent. So this is what we step. Next would be manifold flow valve. Are we recording? Okay, yes. Manifold flow valve. Connect the powertrain control module harness. Turn the ignition on with the scan tool. Actuate the manifold flow valve control to on 100% position. Use a 12-volt test light connected to a ground. Check the control circuit and the manifold flow valve harness connector. Okay, so we're going to see if the computer is commanding the valve actually to come move. All right, so we have to. I had to pull the snap-on scanner out and connect it. It does have actually that the entry, the control. So flow control valve command, toggle on and off. We're probe to pin number 3 now on. That's a 12 volt. Off. So we're good to go here. It says with a test light. I don't know. Should we put a load on it? Test light load? Alright, let's try it. And the instruction says test light, but let's do it with the test light again. I have to do this with 2. Are you guys in the picture? Let me see. Yeah, you guys are going to be in the picture. So, on. Oh, okay, good. Next step would be use 12-volt test light to connect to test light. Should be illuminated and bright. Compare the brightness to that of the right to connect to battery. It's the same one, 12-volt. We saw it right here. It's bright. We have control, so this one's bad. Is it possible that this harness was not plugged all the way? Because the reason why when I unplugged it, I felt that it was not all the way in. So right now, based on the computer, based on the instructions, it tells me to replace this. I'm not gonna replace it. I'm gonna plug the connector and do the test again. By the way, it was not locked. I know I got this to unlock the lock for it. See, like that, it's loose. It's loose. Let me push it all the way in and lock it. Now I want to lock it. There you go. Now it's locked. Now let me actuate it. Let's hear it together. Add it in here. actually what we can do is we can take this off, or we can use one of these here to see the procedure. You guys in? Yes, you guys are in. On, off. On, off. These are bad. They keep bringing bad ones. Made in China. Come on. This one's broken, the casing is broken for it, but let me just try it. Either that or we have a ground issue. I mean, it can be all three of them. I mean, yeah, it can, but no, something's going on. Let me investigate the ground. Although the computer doesn't say or doesn't tell me how to do it, but I have a wiring diagram. I can do it. All I need to know is pin number 1 is a ground. Let's see if we have ground to pin number 1. Switch. This one to power. Although it's not recommended to do this, but no, yeah, no. This ground is not from the computer. It's from the body, from G104. Let's check the ground, and it's pin number 1. Pin number 1 is the top right. Pin number 1 is this one. Do we have reading? Yes, we do. See, you do have 10.81. Why 10.81? Here we have 12 volts. So we should have 12 volts here. When I touch a ground, I should have 12 volts. No good. I think we're missing ground. Let me tell you what. I'm gonna bypass the ground. I think I can by doing this. I'm gonna use my right lead as a jumper to the ground. Actually here to the ground, and this one that failed didn't work with the actuation test. Plug it and probe to pin number 1. Let me just make sure it's a black and white. It's a, you can't miss it. Black and white, pin number 1. Now I hear, okay, I want you guys to hear this. I want you guys to hear this. Do I have a command off? My command is off. But hear this. See it? Okay. Watch this needle. It's not moving. Let me switch it. I just took off the one that was here already, just to make it free. It's not on, off. No good. We just got another made in China new piece. Made in China new piece on, and I did actually remove my jumper, so I just want to depend on the power and ground of the unit itself for now. Let me actuate it. off, nothing. Let me bypass the ground. We have that buzzing sound, on, off. Okay, off, on. Why it's not flopping? So what I did so far, I probed to the control side and the ground, and I'm using my test light here. Again, we on, off, we don't have a signal. Now this is off, on, off. But when I switch my ground to the main ground, now we have a signal. So we definitely have a ground issue to that valve. Now my question is, when I plug this with bypassing the ground, why I don't see this moving? Why I don't see this moving? Should I take care of this first, or should I just find the ground, put everything back, and see if the computer will does it? Will it depend on the other pins that we have? The control, it says control. This is signal 5-volt reference and another ground. Now this is the sensor ground. This is the sensor ground. Could it be? No, because I think it has an internal sensor. This one, I think, has an internal sensor that senses if it's open or closed. So this is the sensor ground, and this is the signal 5-volt reference, and this is the control. I think this is the main ground. The ground. G104. We have to find it, because when I measure resistance between the battery and this black and white pin number 1, I have 19.5 mega ohm. That's a lot. So we have to find it might be a corrosion. We have to find that bad spot. I looked everywhere in all data and Mitchell for G104. I couldn't find it. Mitchell just uses the same figures in all data. Now I'm not gonna stop. We have 2 points we can check at: S108 and C100. I got some pictures for you guys. This is C100. It says engine compartment left rear, so it should be over there. Where is it? C. Right here it says C100. So that should be where? It should be, this is the fender. Should be here somewhere behind the battery, probably under. Now that's a connector. Here's another figure of it. Actually, this is even better. This is from the other side, so it might be behind the fender. I think these. Oh, right here. Okay, that's easy to get to. I don't want to move stuff. I don't want to disturb anything. And S108, right here. I don't know if I recorded this or not, but when I first came to this job, I said, well, what is going on here? I don't like it. But I didn't want to touch anything, because, you know, if it's not broken, don't break it. I want to do this. What I want to do is watch this while I'll be moving stuff. Actually, let me put you on a tripod. Not intermittent. Now what I'm thinking is I'm thinking of unplugging that harness and checking over there. I'll probably without unplugging it, see if I can move this box. All right. There we go. Move the box out of the way. And let me get to it from here. Oh, which one? Is it the one on the left or the one on the right? It is, it looks like the one towards the front. That's 100. It says wire and powertrain. Okay. Just trying to be careful not touching the positive. Black and white right here. Now what I'm going to do, I'm going to move this out of here and measure here. Okay. So even here we have it. Okay, that means our diagram C100. Now I bet you if I do C100 and the harness, let's do that. Let's do between the harness and C100. The harness right here and C100. Okay, now that's acceptable. Do you guys see it? Yeah. That's what I need to see all the time. That means from the harness to C100 is good. So our problem is between C100 and the ground itself, G104, which I cannot find. Let me see if I can follow this harness.
6 months later.
But guys, I gave up. I couldn't find that, and I'm gonna have to expose a lot of big portion of the harness to find it, and it's only here between this harness right here, between this and this. So what I'm going to do, I'm gonna bypass it and put everything back and do our checks, clear the code, see if it comes back on. Everything back on. I bypassed that piece right here in the harness and right here to the body. So let's go clear the codes and see if that code or those two codes come back on. Codes, clear codes, yes, continue, codes, intake manifold runner, position sensor circuit low.